Hi and welcome back to my Merchant Navy How-To series. In this video I will be covering one of my viewer requested topics, which is how to use the nautical tables to calculate the compass error. In order to keep this video short and sweet, I am going to reuse the same calculations as shown in my compass error by Azimuth of the Sun video. The main reason for this is that the initial steps using the Nautical Almanac are exactly the same, so I would strongly recommend that you watch that video before continuing, as I won't be explaining the initial steps in this video. So let's get started. We've already done our sight, noted the information, and consulted our Nautical Almanac to obtain the declination and the local hour angle of the Sun. And we've filled in our pro forma as shown in my other videos, so it looks something like the example on the right. Our next step is to calculate the bearing of the Sun. My pro forma sheet uses a formula method to calculate this. However, if you don't have a calculator handy, it's possible to use the Nautical Tables to complete the calculation. The most common version of Nautical Tables, and the one which is probably carried on board your ship, is the dark blue Norie's Nautical Tables. This book contains lots of different tables for all sorts of different things, but we're only interested in the ABC tables. There are several different editions of the book, so the page numbers that I use in this video may not match up to the edition you have. These tables make use of the ABC method of calculating the azimuth, which you've probably heard mentioned or used in the classroom, and they allow you to use this method without having to do any complicated calculations. The first step is to work out the A component using table A. If we flip through our copy of the tables, you'll find a page looking similar to what's on the screen. The values at the top and bottom of the table are local hour angles, and we go through the pages until we find the table containing the local hour angle we require. In this case 88 degrees 35.2 minutes, which in my edition is on page 398. Having found this, we go down the column until we find our latitude, 25 degrees 50.6 north. As the table only gives whole degrees, some interpolation is required between the figures, and having done this we should get A as being 0.02. Now we have to name it. If you look at the side of the table it explains what to do, but simply put, if LHA is between 90 and 270, we name A the same as the latitude. In this case LHA is not between 90 and 270, so the value of A is 0.02 south. The next step is to work out the B component using table B, which should be on the following page to the one we have just used for the A component, or page 399 in my edition. Again, the numbers across the top and bottom are the local hour angle, so we again find the appropriate column, but this time we go down the column until we find our declination, which was 8 degrees 22.2 minutes. When we interpolate, we get a value for B of 0.15. which, as the note next to the table says, is always named the same as the declination. Therefore the value of B is 0.15 north. Now having found A and B, we need to use these to find C and ultimately the azimuth. C is equal to A plus or minus B. If A and B are both named the same, that is both north or both south, we add A and B together to obtain C. If A and B are named opposite, that is one is north and one is south, we subtract B from A. As in our case A is south and B is north, we subtract B from A, which gives us negative 0.13. C is always named the greater of A or B, which in our case is north, as B was the greater figure, so we throw away the negative sign and obtain our C value as 0.13 north. Now we turn back to our copy of Norie's tables for the last time. We find table C, which has the C values across the top of it, and flick through the pages until we find the appropriate page. In my edition this is page 410. Once we have the appropriate column, we go down the table until we find our latitude of 25 degrees 50.6 north, and after some interpolation we obtain our azimuth as being 83.3 degrees. We said earlier that C is north, as it takes the greater of A or B, and we name it east or west based on the local hour angle. If local hour angle is less than 180 degrees, it is west, and if greater than 180, it is east. Therefore, we obtain our azimuth as north 83.3 west. Azimuth is always referenced to north or south, so we can convert it to a true bearing as we did in the calculation method by doing 360 minus 83.3, which gives us the true bearing of 276.7 degrees. Armed with our true bearing, we can then go on and calculate the compass error as we've done in the earlier videos. As it'll probably come up, eagle-eyed viewers might notice that this is not exactly the same as the true bearing we obtained using the calculation method in the earlier video. This is due to rounding errors which we introduced through the use of the tables, and is not considered an issue for the purpose of calculating our compass error. I hope you found this video interesting and easy to follow along with. Let me know in the comments below, and don't forget to click the like button. As always, my publishing schedule is a bit random due to working at sea, so if you'd like to be notified whenever I post a new video in my Merchant Navy How To series, don't forget to click subscribe. Until next time, happy sailing.